All right, this is number 22 on your chapter 3 review. What it wants you to do is solve for x. So it's e to the 2x minus 5e to the x plus 4 equals, I think it was equals 0. Okay, so what you have to do is, the first thing you have to realize is what this is. This is technically one of those quadratics in disguise. Because remember, you can rewrite e to the 2x. That's the same thing as, and I'm going to write it in different colors because I think this helps, e to the x, all of that squared. Because when you want to simplify this, you just go x times 2, which is 2x. So these two things are exactly the same. And then minus 5, well, e to the x, plus 4 equals 0. So this is just a quadratic. But instead of just plain old x's like we're used to, our variable is e to the x. But if you look at this, this is very, very similar to x squared minus 5x plus 4. But again, instead of x's, I have the whole e to the x thing. Okay? So we're going to solve it just like we would any normal quadratic. There's two ways to solve quadratics. Well, technically three. The first way is factoring. The second way is the quadratic formula. And then if your heart ever so desires, you could use synthetic division, but it's pointless since we have the quadratic formula. So what we could do then is, I'm going to try factoring because factoring is my go-to. I hate doing the quadratic formula. There's just too many places you can screw up. So again, this is just like x squared minus 5x plus 4. So we'd factor it by asking, okay, what multiplies up to 4 but adds up to negative 5? So then normally when we factor, we set up our two parentheses. And we'd put an x here and an x here because that's what our variable is. But our variable isn't x anymore. It's e to the x. So all we do then differently is put an e to the x here and an e to the x here. Okay, so it's just like factoring. Again, what multiplies up to positive 4 but adds up to negative 5? Well, that's negative 4 and negative 1. Okay, so then I have my factored out version. And I solve this just like I would, again, if this was an x here. So I'd set each of these equal to 0. So I get e to the x minus 4 equals 0. And e to the x minus 1 equals 0. I want to get x by itself, so I'm going to add the 4 over, so I get e to the x equals 4. Now the problem is my x is in the variable. Or what did I just say? Sorry, my x is a variable, yeah, but my x is in the exponent. So anytime our x is in the exponent, we have to be able to bring that down somehow. And there's two ways to do it. Since our base is e, though, it makes it really easy because we know something that is the inverse of e. The inverse of e is the natural log. So what you do is you take the natural log of both sides. So anything you do to one side, you have to do to the other. Well, the natural log and e are inverses, so they'll cancel out, and you'll be left with x equals the natural log of 4. And then we got to do the same to this side. E to the x, I'm going to add 1. Take the natural log of both sides. So I'd get the natural log of e to the x equals the natural log of 1. Well, natural log and e cancel each other out. So I'd get x equals the natural log of 1. So if you do not have a calculator tomorrow, which you will not, but if you don't have a calculator, this is as far as you can go. Oops, I don't know why I crossed that out. These would both be your final answers. So the natural log of 4 and the natural log of 1. If you do have a calculator, you can then type in natural log of 4 and natural log of 1. If you type in the natural log of 4, you get it's approximately, I think, 1.386. And the natural log of 1, remember, what does that mean? It means e to what power equals 1? Well, that's 0. That one should always just know that one's 0. So your two answers are x is 0 and x is about 1.386. Again, on a test or a quiz, since you don't have a calculator to find the approximates, you could just leave it as this. Although you should know ln of 1 is 0, but I'd give you credit for getting this far. So, that is how you do number 22. It's just a quadratic in disguise. So you'd solve it just like you would any old quadratic and then take it one step further down here by taking the natural log of both sides. Good luck!